Ensuring continuous power flow through transmission lines is crucial, and interruptions should be minimized. Faults on overhead lines can be either transient or permanent. Transient faults often clear themselves without intervention, allowing the relay auto-recloser to close the breaker after it has opened due to the fault. Fault types: transient faults. These faults disappear quickly, often without any action. About 80 to 85% of line faults are transient, and a single reclosure attempt usually resolves them. Common causes include lightning, insulator flashover, swinging conductors, temporary contact with objects. Semi-permanent faults. These require more than one de-energized interval dead time to clear. Approximately 10% of reclosures are successful on the second attempt. A typical cause is a tree branch falling on the line, which burns away when the line is re-energized. Permanent faults. These faults do not clear upon tripping and reclosing and are often found in cables. Possible causes include broken conductor, collapse of a line tower, tree leaning against the line, fault in a cable within the transmission line. For operators of power transmission and distribution networks, safety and minimizing downtime are paramount. Faults are inevitable, but devices like auto-reclosers help mitigate their impact. Auto-reclosers are particularly useful in overhead cable networks, where only about 7% of faults are permanent. The majority, around 80%, are transient and clear quickly, while the remaining 13% are semi-permanent and typically resolve in a short time. Auto-recloser, i.e. Auto circuit recloser or automatic recloser, which is a recloser switch, i.e. high-voltage switchgear which integrated CTP-TVS equipped with protection relay controller to detect and interrupt momentary faults automatically. For overhead distribution networks, the majority of faults are transient, such as lightning strike, surges or foreign objects coming into contact with the exposed distribution lines. By this logic, 80% of outages can be resolved by a simple close operation. Reclosers are designed to handle a short close-open duty cycle, where electrical engineers can optionally configure the number of attempted close operations prior to transitioning to a lockout stage. So people say recloser, which are often used as a key component in a smart grid, as they are effectively computer-controlled switchgear which can be remotely operated and interrogated using SCADA or other communications. This isolation followed by re-energization process is exactly what an auto-recloser does. In principle at least, it's a simple device. Essentially, it comprises a circuit breaker with associated protection relays, a mechanism that will allow it to be closed automatically after a trip, and a controller that provides the auto-reclose functionality. The ANSI standard device number for the controller is 79. Typically, the complete assembly is installed at the top of one of the poles or towers used to support the power lines. Relay parameters: action time. The action time is started with the start of the fault detection. An AR cycle is only started if a trip command is issued before the action time has elapsed. Dead time: minimum time required to the relay for the reclosure of circuit breaker once the CB is tripped. The time is started once circuit breaker operates. Reclaim time: minimum time for the successful completion of auto-recloser cycle and circuit breaker closing. If during this time trip occurs again, the second cycle of auto-recloser will run in case of multiple shots, or first cycle will be completed as unsuccessful, i.e. CB opened in case of single shot. Blocking lockout: following condition shall block the auto-recloser cycle if all reclosing shots have been carried out and a new fault occurred during reclaim time. Breaker is closed manually. Breaker is not prepared for reclosing. Communication link failure between line protection. Number of shots: no specific standard to decide this. However, this depends on the frequency of the different types of fault occurring in the system and the likelihood of a successful reclosure with 1 or 2 shots. More number of shots require early CB maintenance. Repeated reclosure attempts on high fault may have a serious effects on system stability. The operating principle of an auto-recloser is equally simple. When a fault is detected, the breaker trips. The controller then waits for a predetermined time before reclosing the breaker. If all is well, that's the end of the process, but if the fault persists, the breaker trips again and, after a further delay, the controller recloses it for a second time and checks again for the continuing presence of the fault. If the fault is still present after the second reclose, the breaker trips yet again. Clearly, this cycle of closing and tripping could, in theory, continue indefinitely, but this would be pointless since a fault that persists for more than a few seconds is likely to be permanent. And, of course, continually de-energizing and re-energizing a line would create a safety hazard as well as potentially degrading network stability and risking further damage to assets. For these reasons, auto-reclose controllers are designed to lock out after a certain number of trip reclose cycles, usually 2, 3, or 4 cycles, depending on the application. Types of auto-recloser: high-speed single-pole reclosing, high-speed 3-poles reclosing HTR, delayed 3-phase reclosing DR, DR with a deadline DL and synchronism check SC, HTR with DL and SC, HTR with parallel line check PCE. Auto-reclosing selection: following factors affect the selection of system dead time, system stability and synchronism, type of load, CB characteristics, fault path deionization time, protection characteristics. System stability and synchronism: in order to reclose without loss of synchronism after a fault on the feeder, the dead time must be kept to the minimum permissible consistent with deionization of the fault arc. The use of high-speed protection is essential. CB must have very short operation times and then be able to reclose the circuit after a dead time of 0.3 to 0.6 seconds to allow for fault arc deionization. Type of load: various type of consumer load affects the dead time selection. Industrial consumers: in this case the dead time should be long to ensure that all motor drives have time to be disconnected from the supply. Motors need time to fed out the voltage during its retardation time. Otherwise there is risk of out-of-phase voltage with the network when the reclosing takes place. Domestic consumers: in this case a brief outage does not cause too much inconvenience. A dead time of seconds or a few minutes will be far better than a longer supply failure that can occur without auto-recloser. Circuit breaker characteristics: time delays imposed by the circuit breaker during a tripping and reclosing operation must be considered. Mechanism resetting time: time required to reset the trip-free mechanism before applying closing pulse. Closing time: time interval between the energization of the closing mechanism and the making of the circuit breaker contacts. Deionization: time required to the deionization of the arc, to prevent the arc restriking when the voltage is reapplied. The deionization of fault path depends on several factors. Fault duration, fault current, wind condition, air humidity, air pressure, circuit voltage, capacitive coupling to adjacent conductors. Protection characteristics: it is essential that the reset timing of the protection device must be less than the dead time. Different protection scenarios can be possible as given below. With communication link, dead time can be set less than 0.8 seconds. In this case the circuit breakers at both ends shall be tripped almost simultaneously. Without communication link, dead time can be set around 0.8 to 2.0 seconds. In this case it is necessary to wait for the second time step of the distance protection in order to trip both ends CBs. Delayed auto-reclosing: dead time can be set 2.0 seconds to 3 minutes or system practice. This is normally used for 3-phase auto-reclosing, mainly in distribution network when the line can be fed from both ends. Necessary to check the phase angle, voltage and frequency in certain cases by synchro check relay. Auto-reclosing types: different types of auto-reclosing have been adopted to meet the system requirement. It can be categorized as high-speed auto-reclosing. First requirement of using high-speed auto-reclosing is knowledge of the system disturbance time that can be tolerated without loss of system stability. This is usually in practice to both single and 3-phase tripping and closing. In addition, system voltage, phase angle, and frequency difference may be avoided. Delayed auto-reclosing: in this case, no problems are there related to fault arc deionization time, CB operating characteristics and power swings on the system decay before closing. All tripping and closing shall be 3-phase only. In addition, the practice of checking system parameters before closing. Why is high-speed reclosing type recommended for the generator transmission line? As per generation engineer point of view, main advantages are the stability of machine, in this case generator, and minimum outage. What is dead time and reclaim time? Auto-recloser function is used for transmission line protection system to avoid tripping during transient fault of the line. The function is available in the distance protection relay, however separate auto-recloser relay is also available for using the function. Function of auto-recloser relay: we know that the distance protection relay is used to protect the transmission line during any fault of the line. There are many types of fault occurred in the transmission line. Some of the faults are transient, which occurred for some moment and clear the fault automatically. Lightning is the perfect example of transient fault. During lightning on the transmission system, the phase-to-earth fault occurs and which is in transient nature. Whenever any phase-to-earth fault occurred in the transmission line, the distance relay detects the fault and it will trip that phase of the circuit breaker of the line to isolate the fault. Except for that phase, other healthy phases will remain close position. The open CB pole of the faulty phase is again close after 1 second by an auto-recloser relay. If the fault is in transient nature, in that case, the fault may clear within 1 second and after the closing of the CB pole, the line will hold or power will remain flowing. If the fault is persisting in the transmission line, then the distance relay detects the fault again and it will trip all the 3 phases of the circuit breaker to isolate the line permanently from the substation bus. In this auto-reclose function, the tripping or outage of the transmission line can be avoided at the time of the transient fault. The use of auto-reclosers brings many benefits for network operators, not the least of which is that it minimizes the power interruption time resulting from faults. This helps the network's operators to improve their performance in relation to the SAIDI System Average Interruption Duration Index, SCIFI System Average Interruption Frequency Index and MAFI Momentary Average Interruption Frequency Index standards. In turn, this means reduced loss of revenue. Note that while the SAIDI, SCIFI and MAFI are US standards, comparable network performance standards apply in Europe and in most other parts of the world. Benefits of using auto-reclosers. Auto-reclosers offer several advantages: enhanced system stability, they help maintain continuous power flow. Reduced manpower requirements, no need to visit fault locations to reset breakers. Improved customer satisfaction, shorter power interruptions. Unattended substation operation, easier to manage substations remotely. Blocking feature, an auto-recloser can open during a fault and reclose after a delay or immediately. Engineers must define the number of allowed reclose attempts. For example, if 3 reclose attempts are allowed, the auto-recloser will block further operations and remain open after 3 open-close cycles. Block mode AR block. Before sending a close command, the relay checks the following conditions: circuit breaker CB health. If the CB is unhealthy, the AR function is blocked. Fault detection. If a fault is detected in SOTF, Zone 3, or Zone 4, the AR function is blocked. Lockout mode AR lockout. Lockout mode is crucial for auto-reclosers. It activates and trips the circuit breaker directly under these conditions. AR block command, received after any phase trips. Multiple phase faults. If a fault is detected in another phase during the reclaim time of a single phase fault. Reclaim time. Reclaim time is the period during which the AR relay will not accept any reclose commands. It starts when the auto-reclose function is initiated for any single phase and ends after the reclaim time, making the AR relay ready for another reclose command. The reclaim time depends on factors like the fault incident, CB spring charging time, and TZ2 zone delay time.